When I ask someone what CDN is, people usually say, CDN, well, it rings a bell, but I need to Google it. And then when immediately I ask them, well, do you know what cache is? Cache, have you heard of cache? Oh, cache, yeah, browser cache. Like it's this thing, it's cache. You clear it and everything becomes fine. All problems go away. Or someone cleared their cache accidentally once and then they lost their autofill passwords and many other things they used to have available on their browser. On this video, we will break down what CDN, Content Delivery Network, is, how you interact with Content Delivery Network almost on a daily basis, I'm sure you do, and why it is so important for many companies, for many brands, and for modern day computing. To start with, we have users using internet globally. And this is nothing, there is nothing new about it, right? We know there are people in Boston who use internet. There are people in London who use internet. And let's add one more note. There are people in Singapore who use internet, okay? All of them use internet. That's something all these three nodes have in common. But what is the thing that is different for three of them? It's their location. They are located on different continents, I'd say, because Singapore is Asia, Boston is Americas, and London is Europe. Meaning that there is, to start with, there is literal geographical distance between these three nodes. And imagine we have an application located in Boston. Okay, we have a streaming application or somewhere where they can watch live football, okay? And users connecting from London, their traffic will be traversing all the way from Boston to London to reach them. And in similar fashion, the traffic will be traversing from Boston to Singapore to reach these users. And in the similar fashion, when users from London will want to fetch something from the application, when I say fetch something, it's basically send a request. When you enter Google, you send a request to Google server. When you search for something on Google, you send a request to Google server. So when you try to fetch something from the application in Boston, the traffic is gonna use BGP to traverse all the way to Boston to get that information. We've talked a lot about how BGP works in my videos about ASN, in my video about BGP, that's why don't forget to take a look. And how do we resolve this problem? Because users in London, there are some persistent users who continue watching even if there is a delay, but there are users who don't want to watch after they realize that there is a delay. They see, okay, this is not loading, like, you know, I'm not gonna watch it, just close it. I have no patience for this, okay? What does it mean for the app? App loses viewers. Losing viewers equals losing money, losing popularity, etc., etc. And no app wants this, okay? More hypothetical explanation, example of this would be a big classroom of children. Let's say we have 30 children in a classroom, okay? And we have only one teacher. And each child asks a question. One of the children asks, what is our homework, teacher? When is our break? What is the next subject? What is our today's topic? What is this? What is this? And teacher's like, oh my God, how am I going to answer to all of them? This is so overwhelming. They're just overwhelming me. 30 questions at once. And how do we resolve this? For example, in British schools, they usually have one teacher and one TA, teaching assistant. And teaching assistant absorbs some of the questions that they know answers on. So we have a teacher and we have a teaching assistant. And teaching assistant knows answers to 10 out of 12 questions, but teaching assistant doesn't know answers to one question, let's say, when is our next holiday? And only for the questions that it doesn't know answer to, it approaches the teacher and asks her, okay? And now they are able to distribute the traffic between them vis-a-vis questions from the pupils by answering to the pupils that are closest to them. And this is how the CDN works. The first and foremost goal of CDN is to address latency. By addressing latency, what I mean by latency is when there is a delay. You're loading a page and there is a delay in loading a page. For us, 4 seconds it's a very fast period of time, right? But if app takes 4 seconds to load, it's like 40 milliseconds, right? And it's a long time for an app, because in networking, milliseconds matter. By resolving latency, it reduces distance, it reduces congestion, and it reduces routing hops. But how does it do this? Like, we've talked a lot already about CDN for a few minutes already. How does it achieve this? It achieves this by placing servers in edge locations. When I say edge, it means closer to the main groups of customers, to the main groups of users. So there is an app in Boston, okay? And it has web servers in Boston. However, it creates additional web servers, edge computing, a CDN in London. Then it creates another CDN in Singapore. I can't say they just create a CDN, but the more correct explanation for this would be they create data servers in those locations, because you can't create a CDN. What is CDN? Okay, these are physical data servers that store and distribute data to edge users, to users closest to them. Because when traffic goes to Boston app, it looks at the location of the source of the traffic. And if it's the source is London, it doesn't go to Boston. It goes to CDN, London-based CDN. And same for Singapore. It doesn't go to Boston, it goes to Singapore CDN. What are the main use cases for CDN? Among many others, because realistically any application can use a CDN, correct? But main use cases are video, streaming, gaming, and just streaming of series, streaming of movies. Any other streaming type is also a use case for CDN, because when the traffic passes or goes all the way to the other continent to deliver the video, to deliver the streaming data, it reaches the users later. And in that case, imagine you're playing an online game or you're in online real-time tournament. It makes your life harder if you receive everything with a delay. And similar to a work call, imagine you have a work call, you have a presentation, 20 people on it, and then whatever you say comes with a latency, with a 5-second delay. They can put up with you for 5-10 minutes. And after 10 minutes, they're just going to say, you know what, maybe we reschedule the call, or maybe you disconnect and reconnect again. You know, it's not going to go well if the latency continues. There are different names for the CDN. Many people know it by cache, and we will look at it a bit later, that cache is not full name of CDN, but it's a component of content delivery network. And another name is edge computing. Why edge? Because we have a server, web application, okay, and we have CDN nodes at edge, at different geographical locations, okay, that deliver apps traffic to users on edge. But all of them are realistically looking at origin server, which is the app itself. In our case, it's the app located in Boston. Edge computing and serverless edge. It's also called serverless edge because it's not the app itself, okay? CDN is not the main app located in Boston. Decisions, content is generated by one app. It's located in Boston. CDN just distributes this app to edge users, to users close that are further geographically from Boston app. That's why it's also referred as serverless edge, and in most cases what is meant, it's meant a CDN. Then let's look how it works. Let's look at technicalities. Okay, so I am a user located in London, in the UK, okay? And I use Boston app's IP, which is 22.22.22.22 to connect, okay? I'm using this IP. How does it know that I'm in London and I should be routed to London CDN? Why am I not routed to Boston? Why am I not routed to Singapore CDN? Well, the reason is because it's using CDN is almost always utilizing Anycast IP. Anycast. Meaning that there is one IP address, okay, shared by many different servers. server A, server B, server C, server D. Some of these servers are CDNs, content delivery network servers, and one of these servers is the application. And based on the routing logic, when you access this IP, you are routed to the closest location to you, okay? To the closest point of presence, POP. We talked about Anycast in my lecture about IPs. Please check it out if you can. However, this is almost always utilized for CDNs and obviously BGP. CDN is using BGP logic to route the data again to the geographical locations closest to users. There are several add-ons on how CDN uses its power to become a very common feature to utilize by different companies. However, before looking at that, let's delve into cache, okay, into the formula of how CDN operates. We've got user, okay, let me try and take red color. We've got user, and user connects, user located in the UK connects to CDN edge, which is London CDN, okay? From London CDN, at CDN, origin server, if you don't, you won't have that information. Making sure that CDN catches the updated content and is up-to-date content-wise when it stores the file. And also it does the load balancing. When we say CDN, we have a CDN in London, okay? It doesn't mean that we have one data center in London. It doesn't mean that, okay, this is a data center, this is my CDN, I love you. No. It may as well have several data centers, okay? Data center A, data center B, data center C, and they are all interconnected into one CDN. Who said you can only have one data center? You can have several data centers connected between each other to form one CDN. And what you can do is you can load balance with all the traffic coming at you. You can have a logic to distribute this traffic between different nodes of a content delivery network, of a CDN data center. This is one of the things that CDN is utilizing, load balancing. There are add-ons. There are things that CDN is using to become better. Because in anything that we do, be it HTTP protocol, be it TLS, be it TCP, we are constantly improving. Nothing ever stands still, right? We're constantly trying to move forward. And with CDN, it's the same. It's trying to use different methods to optimize how the way it works. Route optimization. You might ask, okay, isn't there the same route, BGP route, between CDN of London to Boston app or user in London to Boston app? It would have been correct. However, modern companies that offer CDN become so powerful, so mighty in a sense, that they have resources to create the backbones. What is a backbone? It's basically the private connection, private fiber connection, if you will, between CDN data centers, between US and London. Yeah, these companies, they absolutely have resources to do that. Meaning that they have their own backbone, their own private connection between origin and CDN. And then they don't care about BGP, right? BGP, it doesn't choose the fastest route. It chooses the fastest route that meets the policy. We talked about it in my video about BGP. And it doesn't want to listen to anyone's policies, right? And it goes through the backbone, meaning that it's an optimized route that is faster. It's using TCP tuning. I will not get into details of this one, but TCP has several parameters. It has parameters like congestion control, TCP timeout, how long it should wait to retransmit the package. And one of the examples, it reduces the congestion control and it reduces the timeout to make sure that the timeout reaches faster and the new TCP connection, the new try to establish a TCP connection is made. Next is TLS session reuse. Well, to be honest, it is an add-on, but it's not news, okay? It's old as time, TLS session reuse. It came with HTTP multiplexing, HTTP version 2. It exists on HTTP version 3, which is less commonly used, but we have covered this in my video about HTTP. So it uses multiplexing to basically pass the connection within the same TLS handshake. In TLS handshake, we say hello and we go through many steps to establish the handshake. I've talked about it in my previous video. Instead of doing the TLS handshake all the time, which spends us time, and time equals money, we use multiplexing. We establish one TLS connection and we pass the data in between during that established connection. And of course, we do the edge compute. Nowadays, many CDN servers don't only pass the data without thinking of what they're passing, but they can do some basic edge computing, okay? They can offload some basic operations from the origin server, from the Boston application. For example, if application has a logic, if user clicked forgot password, send him a new link to reactivate their password. It's a logic, right? It's an algorithm that it follows. Then edge compute can offload some basic logics to do it on the edge, to do it in the CDN data servers. So when there is certain algorithm that has been offloaded, user forgot the password, user clicked on the password. Now CDN sends the recovery link to the user without disturbing the origin. And then of course origin and CDN resync to make sure that they have the same understanding of things and they are on the same page about users who forgot their password and activated it. And ultimately CDN improves user experience and SEO, search engine optimization. I said it. So how do we improve user experience? Easy. When you watch streaming video, when you watch Netflix, you watch it whether you're in Singapore, whether you are in Australia, whether you are in India, whether you are in Africa. You get the data that you want. You watch your series, you watch whatever you want to watch, DepQ for example. And that means you have good user experience. You're likely to continue using Netflix, you're likely to continue using HBO Max and whatever, meaning that you like the application. And search engine optimization, how does it improve Google results? Like that's what search engine optimization is, right? Google is likely to recommend you the web pages that will take you less time to open. Because if you search something on Google, something comes up first, okay, and you click on it and then it's delayed, you're like, what the? You're gonna click back and try to click to other page. If other page loads in the same fashion, you're gonna be like, okay, maybe I shouldn't use Google. Like, what is the other search engines that I can use? Well, search engines don't want you to use other search engines. That's why what they do is they recommend you the websites that are easier accessible. And easier accessible nowadays, because you can be located anywhere, right? Easier accessible means the ones that have presence closer to your geographical location. And in most cases, it means CDN, cache, content delivery network, cache, edge compute, and serverless edge. And that's how the most popular services that we're using on a daily basis are delivered to us in different geographical locations. Thank you for being with me today. Don't forget to subscribe to my channel, to like this video. YouTube algorithm is not very fond of me for some reason, so please help me get discovered. And I'm glad you've made it so far. Don't forget to follow me on Instagram. On Instagram, my content is a bit different. I just share bits and pieces from my life. And I hope to see you in my next video. Have a nice day. Bye.